Hello everyone, this is Mr. Pelt, and today we're going to explore the parallelogram. So parallelogram, by definition, is just a quadrilateral. Quadrilateral just means a figure with, any figure with four sides. Right, that's a quadrilateral. A parallelogram is a quadrilateral where both pairs of opposite sides are parallel. So simply put, it just means it's got parallel sides. Both pairs are parallel. So I've sketched a couple of examples of parallelograms. This first one here, we see those two sides are parallel to each other, and those two sides are parallel to each other. If that's true, it's a parallelogram. So I've sketched another example here where, again, you can see those two are parallel, and those two are also parallel. So that's another example of a parallelogram. A little later, we're going to explore all kinds of special parallelograms. For example, you can have a parallelogram that has right angles. And I'll give you just a little preview. A parallelogram with right angles is just a rectangle. But that is still a parallelogram because, again, those two sides are parallel, and those two sides are also parallel. So if both pairs of opposite sides are parallel, it's a parallelogram, period, end of story. Now what we're interested in is, are there other things that have to be true whenever you have a parallelogram? And of course the answer to that is yes. So we're just going to explore a parallelogram here. So this parallelogram, you see, all I've done is set this up so that no matter what I do to this figure, the opposite sides stay parallel. So I can move things all around, but no matter what, it stays a parallelogram. And I'd encourage you to explore on your own by just kind of sketching different parallelograms, or go to geogebra.org and you can play around with this yourself. But I noticed a couple things that seem to always be true no matter what. The first thing I notice is that the opposite sides are equal in length. So this AB and CD are both right now 3.2, and AD and BC are both 2.5. And I notice that no matter what I do to this parallelogram, those opposite sides are always equal to each other. So that's always true for a parallelogram. So one of the things that's always true is that opposite sides are congruent. Both pairs of opposite sides are congruent. So that's always true. Next thing is, I also notice that the angles seem to be equal. So the opposite angles seem to be equal. I notice right now they're kind of decimals, but that doesn't really matter. I'll see if I can, it's actually kind of hard to make them whole numbers, but that's okay. I notice that angle D and angle B, no matter what I do here, if I make it really kind of long and skinny or kind of upright, the opposite angles seem to be equal to each other. So I notice B and D are equal. Oh, there we go. And A and C are also equal. And that turns out to also be true for all parallelograms. So another thing we can say is always true is that the opposite angles are congruent to each other. So those are two things that are always true. Another thing I notice, if I look at any two consecutive angles, and what I mean by that is, let's say like angle A and angle B, right side of two in a row, if you're going around the parallelogram, A and B are consecutive, B and C are consecutive, and so on. They seem to always add up to 180 degrees. 73 and 107, they add up to 180 degrees. If I change it to something else, it seems to also always be true. Again, trying to get it on a whole number, it's a little tricky, but anyway, you can see that they still seem to be supplementary. They add up to 180. Well, we actually know that's true because those are same side interior angles formed by parallel lines. You may remember from our study of parallel lines that those have to be supplementary. So another thing we can say is true about all parallelograms is consecutive angles are supplementary. That's always true. Consecutive angles are supplementary. So that's always true. So again, when you have a parallelogram, all of these things have to be true. Now, another thing we're going to be interested in is the diagonals, what we call the diagonals of a parallelogram. So those are the segments that go from opposite corners, right? So if we look at those diagonals, I'm interested in what might be true about those. Now, the first thing I notice is that while they might be equal, there might be situations where they're the same length, like here. It's pretty easy to make a parallelogram where they're not equal in length. Here, clearly AC and BD are not the same length. I don't have the measurements turned on, but I think it's pretty obvious that they don't have to be equal. Right here, BD is really short, AC is really long. But what I do notice is they seem to divide each other equally. Right? It looks like, and I'm just going to mark this point here. It looks like that point, give it a name, point E there, is in the middle. It looks like E is the midpoint of BD, and it also looks like E is the midpoint of AC. And that turns out to always be true. And you'll notice that seems to be the case no matter what I do to this parallelogram. No matter how I move it around, it seems that they split each other equally. So the way we describe that is to say that the diagonals bisect each other. They cut each other into equal parts. So that's another property, another thing that is always true about parallelograms. That's all for now. Thanks.